Okay, as you watch more and more YouTube videos, you start to realize that, questions, they're just repeated over and over again. The image I'm giving you here comes from a textbook I used to use at Essex, a Rogalski textbook, which I think is an excellent textbook, by the way. Excellent set of problems. It's a big book. It's got a lot of good resources, and I think it's a really good book. We don't use it at Essex anymore, but I still use the problem, all right? Now, this problem is not unique to Rogalski's book. You would see this in other calculus books, which is remarkable. Most math books you're looking at, you're going to see not only the exact same problems, but similar problems. Now, certainly they may change the number up here, like to like a 3 to a 5 or whatever. It doesn't matter. But I got to understand what they're asking me to do over here. And by the way, the picture is helpful. It says compute the total area of the infinitely many triangles in the figure. Wow. So let's talk about one triangle at a time. And let's start here. We'll talk about this one here. I'm going to say the area of a triangle is 1/2 times the base. Well, if you're looking at that base over here, I'm going to be careful to write it down, by the way. It's going to be 1 minus 1/2. That's the base of it. What's the height of it? The height's 3. That one's done. Let's go to the next one. What's the next one going to be? Plus area of a triangle, 1/2. What's the base? Well, looking at it, I see the picture. It's 1/2 minus 1/4. What's the height of that? 3. Let's do the next one. It's a nice pattern to it. I'll write a sum down later. 1/2's the area of the triangle. Let's see. Let's put the next one down. What's that going to be? 1/4 minus 1/8 times 3. And you could keep writing this down. I mean, it's got a really nice pattern to it. What's the next one going to be? And unfortunately for a lot of students, they think that's where it stops. And it's not where it stops. It's an infinite number of them. That's going to be 1/8 minus 1/16 times 3. Right? But this goes on forever. Right? And they get smaller. They definitely get smaller. I want to write it as a summation problem now. Right? So if I write a summation problem, the area that they're looking for, I'll call it A, is a sum. And by the way, I'm looking at these terms over here. And I notice every single term has a factor of 3/2 in it. I'm going to pull that out. Let me get my eraser. It doesn't look right. And that's going to be n equals something. But I had 3/2 everything. So, and I look at this thing, and I want to write down what I'm seeing over here. And I got to write it as a summation. Right, I'm looking at it. And it looks like something to do with a half, by the way. So I'm going to say over here, I'm going to start at 0. And it looks like I'm getting, and I'll check it, by the way, 1/2 to the n, which would give me the 1. And then minus 1/2 to the n plus 1. Let me see if that's true. Again, I see the 1/2 times 3 every single time. And this goes on forever. Now, let me just, sort of like chase one route at a time. If n is 0, I get 1. Then I would get 1/2. If n is 1, 1/4, 1/8. And these guys over here, just looking at it, what do you get? Minus 1/2. Yeah, if n is 0, I'd get that. I get this every single time. This is good news. All right, so what I want to do is kind of split it up. 3/2. Sum. N equals 0. They're geometric, by the way, and their convergence goes off to infinity. I'm going to put down 1/2 to the 0. I'm sorry, to the n. Sorry about that. Then minus 3/2. The sum, n equals 0 to infinity. And that's going to be 1/2 to the n plus 1. The first one's perfect, by the way. It's exactly what I want for a geometric. I want it to be starting at 1. It is. But the second one's not so good. So what I'm going to do is rewrite it. A, 3/2. And again, the first one is super simple to do. What are you going to get over there? Let's write it down. It's a convergent geometric series. You can get 1, and then 1 minus 1/2. We'll do the arithmetic later in that. Now I'm going to do plus the sum. I'm going to factor out a half. Whoops, sorry about this. I didn't mean to put plus on. It's my first mistake. I should say my first mistake, another mistake made. So what do you get over here? Minus, whoops, minus, I'm going to factor half out, so I'm going to put 3/4, the sum, n equals 0 to infinity, and it's going to be 1/2 to the n now. All right? Let's see if we can do that now. What do you get? I'm going to put this over here. A equals 3/2. Again, I'm working on this term here. I can multiply the top by 2, I get 2. The bottom would be 2 minus 1, which is 1. Let's do the next one, minus 3/4 times, well, I got the same sum. What are you going to get? 1 over 1 minus 1/2. Let's keep moving. This is still A. What do you get over there? Let's see, 3 minus, let's see, you get 3 there. And if I multiply by 4 on the bottom, it's pretty easy to do. You get 4 minus 2, which is 2. 3 minus 3/2 is going to be 3/2. Look at the K. Make sure you're looking at that as an answer over there. All right? Thank you.